Hello, everyone. In this video, we're going to look at section 8.1 in our workbook on sequences. So to get a sense of what sequences are in mathematics, let's go ahead and start looking at this first example, example 1. So in this example, we're told to suppose that we invest $10,000 into an account that earns 5% annual interest compounded monthly. So that means throughout the whole year, we're earning 5% interest, but that interest is gathered or collected each month. And we'll see what that means for our account. You might have seen this type of work before dealing with compounded interest, but if you haven't, that's okay too. All right, so let's continue reading. At the end of the nth month, let A sub n be the total amount of money in your account in that nth month. So now we're asked to complete the table shown to the right, then describe the behavior of the sequence A sub 1, A sub 2, A sub 3, ... of the account balances. So here we see that word sequence come up, and maybe we can extract what that word means based on context. We'll see a formal definition below, but what a sequence in mathematics mean is just a list of numbers. So this A sub 1, 2, 3 list is a sequence. All right, so let's go ahead and work out this example. All right, so a couple things to note here. We're told that we have this 5% annual interest. I'm going to write that out, 5% annual interest. But since we're compounding each month, we're going to earn a 1/12 of that 5% interest each month. So if we want to fill in this next line of the table, we're looking at when n is equal to 5. So what we're going to do is start with the money in the account for that previous month. So we started with this 10,167.71 cents. And now at the end of that month, then we're going to earn 5% interest divided by 12, because that annual interest is divided into the 12 months. So at the end of 1 month, we're going to earn 0.05 over 12 interest. So we calculate, we multiply there to find the amount of interest, and we can just get out our calculator. You should be getting something like $42.37. So that is going to be the interest earned in the 4th month. And actually, rather, we're starting, this first is the 0th month. So this 4th is actually the 5th month. So we'll say the 5th month of having money in the account. Okay, so what does that mean? So therefore, for our account, the start of the next month, we'll have the original $10,167.71. But now we're going to add the interest accrued from the previous month. So we're going to add $42.37. All right, so getting out our calculator, we should compute that this is going to be around $10,000, $10,210.08. So then in our table, we can go ahead and fill that in. For when n equals 5, we have 10 to 10.08. And the interest that we accrued that month is right here. We already calculated it. So we're going to fill that into our table. So we have $42.37. All right, so now we can do this for when n equals 6. So we look at that previous balance. So that previous balance was 10,210.08. And now we're going to compute 5%, or a 1/12 of 5% of that, which is going to be, you can get out your calculator to check me. It's going to be $42.54. So that's the interest made in that next month. Interest earned in the 6th month. It's a pretty good deal. 5% interest, annual interest, compounded monthly. All right, so then what would actually be in our account? Well, actually, first we can fill in that interest up here, $42.54. There's that interest. So then what's actually in the account? Well, we started with the previous balance of $10,210.08. Now we're going to add on that interest of $42.54. All right, so when we add those together, we get $10,252.62. So that's what's going to go in this final cell here. $10,252.62. Awesome. Nice work. So now let's consider the sequence that we're creating, these A sub n sequence. So again, in this case, the sequence is just this list of numbers. So starts with 10,000, then 10,041.67, 10,083 and 50 and 0.51, 10,125.52. I don't need to read all these to you, but what are some things that we can observe about the A sub n sequence? So we can write the sequence, and we'll learn exactly what that means here in a little bit. The sequence A sub 1, A sub 2, A sub 3, ... of account balance, the account balances. What do we notice about it? Does it increase or decrease? Or does it not always increase or decrease? Well, since each month we're adding more interest into our account, these numbers always increases. So these annual account balances will continue to increase because each month we are creating or we are collecting more interest. All right, so there's something we can say about the behavior of the sequence. And notice we say here that it continues to increase. So you might be asking yourself, well, doesn't this happen of every list of numbers that increases? Won't it continue to always increase? And we'll make a little bit more sense of that here when we see some more examples. So let's finish this video off by looking at this formal definition of a sequence. So here's our formal definition. A sequence is a list of numbers written in a definite order. So in notation, we write our sequence. If we are using the letters S to represent the numbers in our sequence, we have S sub 1, S sub 2, S sub 3, ... through S sub n. And we call that sequence this curly parentheses or curly bracket with S sub n. That's how we shorthand this list of n numbers. We say that an infinite sequence, so if this n is not just stopping at n, but we actually have an infinite amount of numbers, it converges to a value L or has a limit L if we can make the numbers in our sequence arbitrarily close to L by taking n sufficiently large or big enough. Meaning our sequence converges to this number L if we can get as close as we want to L without going over, without blowing up, by taking n large enough. So as n goes really, really large, that values of our sequence get closer to L. Otherwise, the sequence S sub n converges to L. Or if rather the sequence S sub n converges to L, then we write that the following way. So then we write that as the limit as n goes to infinity of S sub n is equal to L. So this should feel a little bit familiar with what you've seen when we've looked at limits of functions. So in that case, the function, when we've seen these types of limits before, we're looking at is like an f of x, and we're taking the limit as x goes to infinity, say, equals L if it does converge. So here we can think of this n as like the input of a function. So you want to know the output? Well, what number of the sequence are you looking at? Okay, awesome work thinking through this. The next videos we'll look at some more examples. Thanks for watching.